So in this video, I want to put into place the things we know about exponential graphs and try and do these without a calculator and try and make up some equations and find some missing values. So the first thing I need to see is that I've got some negatives here, exponents, and negative exponents come down. So this one comes down, this one comes down, and a positive exponent goes up, positive exponent goes up. So how can I match, say, the 9 with a negative as I have two negatives, one here and one here. I've got two negatives. How do I tell the difference between those two? Well, the 9 to the power of negative x is steeper than the 2 to the power of negative x. The higher the number there, the steeper it is. So the steepest one is here, so that matches with that. And this one will match with the other one that's negative here. Now the same thing happens here. This is the steepest graph, and I believe that this is steeper than this one. All the graphs, they all go through 0, 1. That's something that's common to all the graphs until I start doing the transformations. Okay, let's start looking at a question here. I've got to find A, B, and C, and I've actually got 3 points of information on this graph. I've got this asymptote here, and this asymptote here is y equals -4. And I can tell you straight away that C is equal to -4. That's the first one, because we should have noticed that normally before I do any adjustments, the asymptote is at 0, y equals 0. The C brings that down, -4. So now let's use this coordinate here and see what that gives us. That's telling us that when we put 0 in, I get -2 out. So -2 comes out when I put 0 in. So I've got A times B to the power of 0, and I now know my C number. So a bit of rearranging becomes 2 if I add 4 to both sides. B to the power of 0 is 1, so A is 2. So I've got my C value. I've got my A value. Now let's use the other point to get my B value. So 2 is equal to A, which is 2, times B to the power of 1, take away 4. So a bit of rearranging. I'm going to add 4 to both sides, so it gives me 6. Divide both sides by 2, and it gives me B to the power of 1. So B is equal to 3. So I've got all my values, A, B, and C. Let's do one that's slightly harder. So here I've given you the fact it's -x, and we can see that it's sloping downwards. It's what we call a decay curve. So first thing, the C value is 1, because that green line there is y equals 1. So my C value is 1. So that's pretty straightforward. Now we haven't got the coordinate that it goes through here, but they do give us -2, 2. So let's have a look at that. That's 2 comes out when we have the A value, don't know what that is, times the B value to the power of -2, and then I'm adding on 1. Now here we can see that we've got 1 equals AB squared. Now that doesn't really help me because that's one equation with 2 letters that I don't know. Let's use the other point and see what happens. So that's saying that 5 comes out when I have A times B. B is -4, and we've got the negative, so it becomes B to the power of 4 plus 1. Bit of rearranging. 4 equals A, B to the power of 4. Okay, well now I have 2 equations, 2 unknowns. So it's definitely a simultaneous equation. So let's go back up to that first equation and let's make that A is equal to 1 divided by B squared. Let's substitute that in to the next one. So now we're going to go 4. Now let's not use a, let's use 1 over b squared instead of a. So we're replacing that a with that, and then times it by b to the power of 4. When we rearrange this equation, we have b to the power of 4 divided by b to the power of 2. So we've basically got 4 equals b squared. B to the power of 4 divided by b to the power of 2. So b is 2. So I should also say I've got c at there, that's no problem. Now I've got b. Now let's use this here. A equals 1 over b squared. So therefore, a is a quarter. Okay, so we've got all our values. C is 1, A is a quarter, B is 2, and there we are. There's our answers there. So this hopefully is just showing you how I can find those missing values from exponent graphs.